In this video, we're going to be talking about how to use transformations on non-parent functions. I thought before we would do that we would review how the vertex form of any function does affect its shape and position on the coordinate plane. So the vertex form of a function labeled f of x has three letters. The front letter, which is normally labeled a, will multiply all y values or output values. The b, which is inside of the grouping symbol, so this parenthesis could be an absolute value symbol, is the first thing that appears inside of that. It has to be factored out using GCF factoring to determine its value and to also determine the true value of h, and it will divide all of the input values. Once you've factored b out, you can find out what h is. H is sometimes labeled c, and k is sometimes labeled d, but for our purposes, we're going to label it h. That is going to add or subtract, we don't know if it's positive or negative, to the x value. So clearly, order of operations matters. You would want to divide the input values by b before you then add or subtracted the h value to those input values. The parentheses will tell you if the shape of the graph or what parent function it is. Sometimes that will be in coordination with an exponent. For instance, if this were the cube function, this would be a parentheses with a cube on it. The k, which is outside, and it is the easiest letter, sometimes again labeled d, will add or subtract to the y values. But remember, that's going to happen after you have multiplied first. So order of operation is important. If you have an a with a k, you would want to multiply before you add it or subtract it. Just a review of what I said in a little more verbal sense. A is going to stretch vertically the graph if it is greater than 1. And if it's between 0 and 1, it's going to compress the graph because you're multiplying that value times all the outputs. If you multiply it by a value larger than 1, it's going to get bigger. If you take 1 and you multiply it by 3, that's now 3. It's going to stretch. But if you multiply by a fraction between 0 and 1, like a fourth, it's going to compress and make it smaller. The reason the a isn't an absolute value is because of the fact that the negative sign reflects over the x-axis. So the reason that these notes are written with an absolute value is the negative needs to be treated differently than the actual value of a. So that's why that's written that way. Keep in mind also that the vertex, which I'll talk about more when we do h and k, is always labeled opposite of what you see of h, comma k. Meaning if there's a 3 here, right, it actually says -3, but the value of the vertex would be 3, opposite of what you see in h. Okay? So b is similar to a in terms of looking at the absolute value of its value, but it will compress because it's a divisor. Remember, a is a multiplier, but b is a divisor. So what that means is that if b is 2, it's going to divide all the inputs by 2, making them half their size. That's why it's a compression. But if I divide by a b that's between 0 and 1, if I divide by a half, that would reciprocate and then multiply, making it a stretch. The reason that's an absolute value is the same reason here. The b, if negative, will reflect over the y-axis. And then once you take the absolute value, you can then compare whether or not it will cause a compression or a stretch. H, when negative, translates the graph left. When positive, translates the graph right. Remember, h is always the opposite value as it appears in the equation. K, the easiest part of the whole thing, what you see is what you get. If it's negative, it translates the graph down. When positive, it translates the graph up. So for my more just verbal students, I have another little review here that I think would be helpful. And again, you might want to, at this point, pause and write down these notes in your notebook if you don't already have them. They are identical to some previous videos. These are new. So you might want to pause and write down these notes to just add to that page or add as a review at the end of the unit. So again, if you notice what I have here, here's h, right? So the translations occur, the value is opposite of what you see. So whatever you see here for h, again, if this were x minus 4, the value of h is actually 4. But if this were 8x plus 4, you had to have two negatives here to make that negative become a positive. So it's opposite of what you see. It will translate the graph left to right. It's the x part of the vertex, and it adds or subtracts the input. The K is exactly what you see is exactly what you get. It translates the graph up or down. It's the Y part of the vertex, and it adds or subtracts to each output. Okay, reflections occur, as you can see here. They're just, if it's negative, if you have a negative A value, it's going to reflect the graph through the x-axis or over the x-axis. It will multiply those output values and make all the output values negative, and that's what causes this reflection. If B is negative, it has to be factored out, because if you don't factor out this negative, it's actually going to affect this negative. So keep that in mind. It reflects the graph through the y-axis, and it will divide all the input values, making them negative. The dilations will occur very similarly. So A, if larger than 1, is going to stretch the graph, multiplying it, making it taller, is another way to describe it. It's going to multiply the output values. B has to be factored out. B is a divisor, so it will make the graph smaller if greater than 1. And then keep in mind that if it's a fraction between 0 and 1, the opposite will happen. So a fraction between 0 and 1 here would cut all of the output values by a third, for instance, making the graph shorter. But the way we say that is vertically compressed. But if B were a third, we would be dividing everything by a third, reciprocating it, and then multiplying everything by 3. All right, I hope that was a good review. We're going to take a look at some examples of what it looks like to look at a non-parent function related to all of these different things.